July 14th, 1941. Outside Orsha, Belarusia, Hauptmann Werner Hoffmann pressed his field glasses against his eyes, struggling to comprehend what he was witnessing from his observation post 3 kilometers behind the advancing German lines. The morning had begun with the familiar sounds of Operation Barbarossa's relentless eastward push. Then, at precisely 15:15 hours, the sky above the Soviet positions began to scream. Hoffmann would later write in his combat diary, discovered decades after his death in a Siberian prison camp, "I saw the smoke trails first, not one or two, as from conventional rocket weapons, but dozens, hundreds perhaps. They rose from the forest like a swarm of fire-spitting demons, trailing smoke and flame. The sound was unlike anything I had experienced, not the whistle of artillery shells, but a terrible shrieking wail that seemed to come from hell itself." The target was Hauptmann Hoffmann's own regiment, the 167th Infantry Division, part of Army Group Center, had paused to consolidate positions along the Dnieper River. German intelligence had assured them that Soviet forces were in full retreat, incapable of organized resistance. The assurance had been catastrophically wrong. In 10 seconds, the Soviet BM-13 rocket launcher system, nicknamed Katyusha by Red Army soldiers and soon to be called Stalin's organ by terrified German troops, delivered 320 high-explosive rockets onto a 1 square kilometer area. When the smoke cleared, an entire German battalion had ceased to exist as a fighting force. 473 men were dead or wounded. Every vehicle in the assembly area was destroyed or damaged. The survivors, even veteran NCOs who had fought in Poland and France, were in shock. What the Germans did not know, what they could not have known in those early weeks of the invasion, was that they had just encountered a weapon system so revolutionary that it would fundamentally alter the character of artillery warfare. The Soviets had created something that defied German military doctrine, something that transformed quantity into a devastating psychological and physical weapon. The Germans believed they understood Soviet military capabilities. They had studied Red Army performance during the Winter War against Finland. They had analyzed Soviet artillery doctrine, which emphasized massed batteries firing conventional shells in lengthy preparatory barrages. They expected numerical superiority compensating for technical inferiority. They were unprepared for innovation. The BM-13 Katyusha system emerged from Soviet rocket research conducted throughout the 1930s. Unlike traditional artillery, which used controlled explosions in gun barrels to propel shells, rocket artillery used self-contained solid fuel motors. The technology was not new. Congreve rockets had terrorized Napoleon's forces. The British had used rocket batteries in the 19th century. But manufacturing limitations and accuracy problems had relegated rockets to secondary status in modern warfare. The Soviet Union, under the direction of the Rocket Research Institute in Moscow, approached the problem differently. Instead of attempting to match conventional artillery's accuracy with individual rockets, Soviet engineers designed a system that would saturate an entire area with rockets launched simultaneously. Accuracy mattered less when 320 rockets landed within 10 seconds. Something in that kill zone would be hit. Everything in that kill zone would be terrorized. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The BM-13 launcher, standardized in June 1941, consisted of 16 rails mounted on a ZIS 6x6 truck chassis. Each rail held one M13 rocket, a projectile 1.8 meters long, weighing 42 kilograms, with a warhead containing 4.9 kilograms of TNT explosive. Maximum range varied between 8,500 and 9,000 meters, depending on rocket batch quality and propellant temperature. The launcher itself was deceptively simple. The rails were arranged in 2 rows of 8, angled at approximately 15 degrees above horizontal. Elevation and traverse adjustments were crude, made by manually cranking the rail assembly. Fire control consisted of an optical sight and a basic range table. There were no sophisticated fire direction computers, no mechanical calculators, no elaborate plotting boards. Yet this simplicity was the system's genius. A BM-13 battery could arrive at a firing position, deploy in 3 to 5 minutes, launch all rockets in 7 to 10 seconds, and depart within 2 minutes. German artillery, by comparison, required 30 to 40 minutes to emplace heavy guns, fired at rates of 2 to 4 rounds per minute, and needed an hour or more to displace when threatened by counter-battery fire. The M13 rocket itself represented Soviet engineering pragmatism. The body was stamped sheet metal, welded at the seams. The solid propellant was pressed nitrocellulose, relatively simple to manufacture compared to the complex powder charges required for conventional artillery. The warhead used standard TNT, nothing exotic or difficult to produce. The stabilization system consisted of a simple cruciform tail fin assembly, stamped from sheet metal and welded to the rocket body. Production costs were remarkably low. Each M13 rocket cost approximately 800 rubles to manufacture, roughly equivalent to $20 American. A complete BM13 launcher, including the truck chassis, cost approximately 42,000 rubles, about $1,000 American. For comparison, a Soviet 152mm howitzer cost approximately 95,000 rubles and required a separate prime mover, specialized ammunition limbers, and extensive crew training. The Katyusha system could be operated by minimally trained crews. Soviet training: manuals specified 2 weeks of instruction for a complete launcher crew. German artillery crews required 6 months to a year of training to operate conventional guns effectively. This training differential allowed the Red Army to rapidly expand Katyusha units as production accelerated. The first combat use of the Katyusha occurred on July 14, 1941, near Orsha, the engagement that Hauptmann Hoffmann witnessed. An experimental battery commanded by Captain Ivan Flyarov fired the first salvo at 15:15 hours. The target was the German 167th Infantry Division's logistics area, where fuel trucks, ammunition carriers, and supply vehicles had concentrated near the Orsha railway station. Captain Flyarov's battery consisted of 7 BM-13 launchers, a total of 112 rockets. The battery had arrived at its firing position at 14:45 hours, concealed in forest approximately 5 kilometers from the target. Soviet forward observers had identified the German concentration using conventional optical observation. The coordinates were simple: grid square on a standard military map. Precision was unnecessary. At 15:15 hours, Flyarov gave the command to fire. Each launcher ripple-fired its 16 rockets in sequence, with approximately half-second intervals between launches. The entire battery emptied its rockets in 10 seconds. The effect was devastating, not merely from explosive force, but from the psychological shock of simultaneous impact. German after-action reports, captured when the 167th Division was destroyed later in the year, described complete panic. Vehicle drivers abandoned their trucks and fled into surrounding fields. Ammunition handlers dropped shells and ran. Even experienced officers lost control of their units temporarily. The combination of the terrible shrieking sound during flight, the smoke trails visible against the sky, and the sudden, overwhelming detonation of over 100 rockets within seconds shattered unit cohesion. Material damage was significant but not exceptional. 23 German vehicles destroyed, 41 damaged, ammunition dump partially detonated. Conventional artillery might have achieved similar physical results with sufficient ammunition expenditure, but the psychological effect was unprecedented. German units in adjacent sectors heard about the attack within hours. Rumors spread rapidly, amplified by soldiers' fear and incomprehension. The Germans initially believed the Soviets had deployed some form of organ gun, a multi-barreled automatic weapon firing explosive shells. Intelligence officers attempted to identify the weapon system from survivor accounts, but descriptions were confused and contradictory. Some reports mentioned aircraft rocket attacks. Others described multiple conventional artillery batteries firing simultaneously. None accurately described what they had actually encountered. The Soviet High Command, recognizing the weapon's potential, ordered immediate production, expansion. Factories in Moscow, Voronezh, and beyond the Urals received priority allocations of steel, explosives, and skilled workers. By September 1941, monthly production of BM-13 launchers reached 45 units. By December 1941, monthly production exceeded 100 launchers. Rocket production increased even more dramatically. Factories converted from producing conventional artillery shells to manufacturing M13 rockets. The relative simplicity of rocket production, compared to precision-machined artillery shells, allowed rapid expansion. By the end of 1941, Soviet factories were producing approximately 12,000 M13 rockets monthly. By mid-1942, monthly production exceeded 100,000 rockets. This industrial mobilization occurred while German forces occupied significant portions of Soviet territory, including major industrial centers. The evacuation of factories beyond the Urals, combined with rapid conversion of remaining facilities to rocket production, demonstrated Soviet industrial resilience that German planners had not anticipated. The organizational structure of Soviet rocket artillery reflected its revolutionary nature. The first dedicated Guards mortar units, as they were officially designated for security purposes, were formed in August 1941. The term Guards indicated elite status. The term mortar was deliberate deception, intended to conceal the weapon's true nature from German intelligence. Each Guards mortar regiment initially consisted of 3 batteries, each battery equipped with 4 to 7 BM-13 launchers. Total regimental strength, 36 launchers, 576 rockets in a single salvo. Command structure was centralized under NKVD control, reflecting the weapon's strategic importance and the paranoia of Soviet leadership about security breaches. Security measures were extreme. Launcher crews were forbidden from discussing their weapon system. Maintenance personnel were segregated from combat units. Even damaged launchers were destroyed rather than abandoned to prevent German intelligence from examining the technology. Rocket components were manufactured in separate factories, assembled only at final production facilities, to limit knowledge of the complete system. These security measures worked. German intelligence did not accurately identify the Katyusha system until late 1941, 6 months after first combat use. Early intelligence reports confused rocket artillery with conventional systems or dismissed survivor accounts as exaggerations driven by panic. The first German technical analysis of captured Katyusha components occurred in November 1941, when Wehrmacht engineers examined launcher fragments recovered near Moscow. Their report, preserved in German military archives, reveals their assessment. Soviet rocket launcher system, designated BM-13, represents crude but effective application of rocket technology. Construction quality is poor by German standards. Individual rocket accuracy is insufficient for precision fire missions. However, the system's ability to deliver mass fires rapidly compensates for technical deficiencies. The psychological effect on troops appears significant, possibly exceeding physical casualties inflicted. This analysis, while technically accurate, fundamentally misunderstood the Katyusha's revolutionary nature. German artillery doctrine emphasized precision fire on identified targets. Soviet rocket artillery doctrine emphasized saturation fire on area targets. The Germans evaluated the BM-13 against criteria it was never designed to meet, failing to recognize that it represented a different philosophy of artillery employment. Oberst Heinrich Wagner, commanding the 293rd Artillery Regiment facing Soviet forces near Moscow in December 1941, documented his unit's encounter with massed Katyusha fire in his war diary. The entry for December 8, 1941 reads, 0435 hours. Soviet rocket artillery engaged our assembly areas with intensive fire. Estimate minimum 500 rockets impacted within 5-minute period. Physical casualties moderate, approximately 48 men. Psychological effect severe. 3 platoons refused orders to advance. claiming positions were under artillery observation and movement would draw additional fire. Battalion commander restored order only after threatening summary execution. Wagner's observation about troops refusing orders became a recurring theme in German reports throughout the war. Katyusha fire, even when causing relatively light casualties, induced paralysis. Soldiers who had endured conventional artillery barrages broke under the sudden, overwhelming nature of rocket attacks. The distinctive shrieking sound, caused by air flowing over stabilizer fins during flight, was particularly unnerving, audible 5 to 8 kilometers from launch points. Red Army soldiers called the launcher Katyusha, Little Katy, after a popular wartime song about a girl waiting for her soldier to return from the front. The nickname reflected Soviet soldiers' affection for a weapon that, for the first time since the invasion began, gave them a technological advantage. German soldiers called it Stalin's organ, Stalin Orgel, referencing both its appearance with multiple launcher rails and the terrible shrieking sound of rocket salvos. The nickname spread rapidly through Wehrmacht ranks. By early 1942, German intelligence reports routinely referred to Stalin Orgel attacks. Frontline units developed procedures for responding to Katyusha fire, though these were largely ineffective. Standard doctrine called for immediate dispersion and seeking cover at the first sound of rocket launches. However, the brief flight time, typically 20 to 30 seconds, gave troops almost no time to react. German counter-battery attempts were frustrated by the Katyusha's shoot and scoot capability. By the time German observers identified launch smoke and computed counter-battery fire solutions, Soviet launcher trucks had departed. German forces occasionally captured abandoned launcher trucks, but these were invariably damaged beyond recovery, deliberately destroyed by their crews. The battle for Moscow in December 1941 showcased massed Katyusha employment. The Soviet counter-offensive, launched on December 5th, was preceded by the largest concentration of rocket artillery yet assembled. 8 Guards mortar regiments, totaling approximately 288 BM-13 launchers, supported the attacking forces. Initial barrages delivered over 4,000 rockets onto German defensive positions within the first 15 minutes of the offensive. Gefreiter Otto Kranz, serving with the 252nd Infantry Division north of Moscow, survived the opening bombardment. His account, recorded in a letter to his family that was intercepted by Soviet censors and preserved in archives, describes the experience. "I cannot describe what we endured. The sky filled with smoke and flame, the sound was like the screaming of 1,000 demons. We pressed ourselves into the frozen earth, praying to survive. When it ended, I looked around and saw destruction everywhere. Vehicles burning, positions obliterated, men dead or mad from terror. Those who survived could not fight. We simply waited for the Russians to come, hoping they would take us prisoner rather than kill us." The Moscow counter-offensive drove German forces back 50 to 200 kilometers, the first major German retreat of the war. While Katyusha fire was not the sole factor, its psychological and physical effects contributed significantly to the collapse of German defensive positions. German units that might have conducted fighting withdrawals instead routed, abandoning equipment and fleeing westward in disarray. Throughout 1942, Soviet rocket artillery production accelerated while employment doctrine evolved. Initial use had been somewhat haphazard, with batteries firing at opportunity targets when available. By mid-1942, the Red Army developed systematic fire planning that integrated rocket artillery into combined arms operations. The new doctrine emphasized 3 principles: mass, surprise, and mobility. Mass meant concentrating multiple regiments to saturate target areas completely. Surprise meant concealing launcher positions and firing without preliminary ranging shots. Mobility meant firing rapidly and displacing immediately to avoid counter-battery fire. These principles maximized the Katyusha's strengths while minimizing its weaknesses. The Battle of Stalingrad, from August 1942 through February 1943, demonstrated evolved Soviet rocket artillery doctrine. Guards mortar units supported both defensive operations within the city and the November 1942 counteroffensive that encircled German forces. The urban terrain provided numerous concealment positions for launcher trucks, allowing Soviet crews to fire from within the city and displace through rubble-filled streets. Hauptmann Werner Hoffmann, the same officer who had witnessed the first Katyusha attack near Orsha, found himself encircled at Stalingrad with the Sixth Army. His diary entries from December 1942 reveal the cumulative psychological effect of prolonged exposure to rocket fire. We have learned to recognize the sound. The shrieking begins before we can see the rockets. We have perhaps 10 seconds to find cover, though cover provides little protection. The rockets explode everywhere, in buildings, in streets, in the ruins where we hide. Each attack kills a few men, wounds more, but the greater damage is to our spirits. We know the Russians have unlimited ammunition while our supplies dwindle. We know they can fire and disappear while our artillery is immobile and vulnerable. Most of all, we know that every Katyusha attack might be our last. Hoffmann survived Stalingrad's fall and spent 12 years in Soviet captivity. His diary, confiscated when he was captured in February 1943, became part of Soviet propaganda exhibitions, showcasing German accounts of Soviet military superiority. The encirclement and destruction of German Sixth Army at Stalingrad marked a turning point in both the war and in German psychological resilience. Wehrmacht soldiers began to understand that they were not facing an inferior enemy equipped with obsolete weapons, but a military force capable of innovation, mass production, and tactical adaptation. The Katyusha, more than any other single weapon system, symbolized this transformation in German perceptions. By early 1943, Soviet rocket artillery had expanded beyond the original BM-13 system. The BM-8, a lighter system firing smaller 82mm rockets from rails mounted on various truck chassis, provided greater mobility for exploitation operations. Each BM-8 launcher fired 36 or 48 rockets, depending on configuration. While individual rockets carried smaller warheads, massed fire from BM-8 batteries achieved devastating effect against infantry and soft targets. The BM-31, introduced in late 1942, fired larger 300mm rockets with massive warheads containing 28 kilograms of explosives. Maximum range was 4,300 meters, shorter than the BM-13, but the larger warhead created enormous blast effects. Each BM-31 launcher fired 12 rockets. A battery of 6 launchers could deliver 72 heavy rockets, approximately 2 tons of high explosive, in under 20 seconds. German forces learned to distinguish between different Katyusha systems by sound. The BM-8's lighter rockets produced a higher-pitched shriek. The BM-31's heavy rockets made a deeper, more resonant sound that veterans described as the sound of approaching freight trains. The BM-13's distinctive shriek remained the most psychologically effective, the sound that epitomized Stalin's organ to German soldiers. The diversity of rocket systems allowed Soviet commanders to tailor fire support to specific tactical situations. BM-8 systems supported fast-moving exploitation forces, their mobility keeping pace with advancing tank units. BM-13 systems provided general-purpose fire support for combined arms operations. BM-31 systems delivered devastating fires against fortified positions and urban strongpoints. Production figures demonstrate the scale of Soviet commitment to rocket artillery. By December 1943, Soviet factories had produced over 3,000 BM-13 launchers, over 2,000 BM-8 launchers, and approximately 800 BM-31 launchers. Monthly rocket production exceeded 1 million units across all types. This represented a significant portion of Soviet industrial capacity, resources that might have produced additional conventional artillery or other weapons systems. The decision to prioritize rocket artillery reflected Soviet recognition of its unique advantages. Conventional artillery, while more accurate, could not deliver comparable volumes of fire as rapidly. Soviet artillery doctrine, developed through decades of experience and refined in combat, emphasized the shock effect of massed fires. Rocket artillery achieved this shock effect more efficiently than conventional guns. Moreover, rocket production was simpler and faster than manufacturing conventional artillery pieces. Gun barrels required precision boring and heat treatment, processes that demanded specialized equipment and skilled workers. Rockets required metal stamping, welding, and explosive filling, all processes more amenable to mass production by semi-skilled workers. As the Soviet Union struggled to replace industrial capacity lost to German occupation, this production advantage proved decisive. The German military never developed an effective counter to Soviet rocket artillery. Attempts to create similar systems failed to match Soviet production scale. Germany produced the Nebelwerfer rocket launcher system, but in relatively small numbers. By war's end, German forces had approximately 5,500 Nebelwerfer launchers of all types, compared to over 10,000 Soviet rocket launchers. More significantly, German rocket artillery doctrine never evolved beyond conventional artillery thinking. German Nebelwerfer batteries were organized and employed like conventional artillery, firing pre-planned barrages from static positions. Soviet rocket artillery emphasized mobility, surprise, and mass. This doctrinal difference, combined with production disparity, meant German rocket artillery never achieved the psychological or physical impact of Soviet Katyusha systems. Oberst Heinrich Wagner, the artillery commander who had documented his unit's first encounter with Katyusha fire near Moscow, surrendered to Soviet forces in May 1945. His post-war interrogation, preserved in Soviet military archives, included extensive discussion of Soviet rocket artillery. Wagner's assessment was professional and devastating. The Soviet rocket artillery system represented a revolution in fire support that German forces never matched. We understood the technology. We could have built similar systems. But we lacked the industrial capacity for mass production and, more critically, we lacked the doctrinal flexibility to employ them effectively. The Soviets recognized that rockets, while individually less accurate than conventional artillery, could achieve decisive effects through massed fires. We never fully embraced this concept, remaining wedded to precision engagement of individual targets. Wagner's observation about doctrinal rigidity reflected broader German military culture. The Wehrmacht prided itself on technical excellence and tactical sophistication. Individual skill and superior equipment were expected to overcome numerical disadvantage. Soviet military culture emphasized mass and simplicity. Individual skill mattered less than collective effect. Equipment need not be superior if produced in overwhelming quantities. The Katyusha embodied this philosophical divide. German engineers examining captured systems consistently criticized build quality, noting crude welding, loose tolerances, and basic components. They failed to recognize that these characteristics enabled mass production. Soviet engineers designing the Katyusha deliberately traded technical sophistication for producibility, creating a weapon system that could be manufactured by the tens of thousands rather than the hundreds. The Eastern Front campaigns of 1943 and 1944 demonstrated the full maturity of Soviet rocket artillery employment. Operation Bagration, the massive Soviet offensive launched on June 23, 1944, showcased coordination between rocket artillery and conventional forces that German commanders found impossible to counter. The offensive began with the largest artillery preparation of the war to that date. Over 31,000 artillery pieces and mortars, including over 400 rocket launcher systems, concentrated along a 450-kilometer front. The preparatory bombardment lasted 2 hours and 20 minutes, delivering an estimated 2.5 million shells and rockets onto German defensive positions. General Major Paul Volkers, commanding the 267th Infantry Division defending near Vitebsk, experienced the bombardment from his command bunker. His after-action report, written days before his division was destroyed and he was captured, provides clinical detail despite obvious stress. The bombardment exceeded anything we had experienced on the Eastern Front. Conventional artillery fire was continuous, but the rocket attacks were the most terrifying element. Waves of rockets arrived every 10 to 15 minutes, each wave delivering hundreds of projectiles simultaneously. The shrieking sound, the smoke trails, The overwhelming explosions created an atmosphere of apocalypse. Communications broke down. Units lost contact with higher headquarters. Forward positions were obliterated. By the time the Soviet infantry attacked, our defensive system had ceased to function. Operation Bagration destroyed German Army Group Center, eliminating 28 divisions and costing approximately 400,000 casualties, Germany's worst defeat of the war. While conventional artillery and air power contributed significantly, the psychological shock of massed Katyusha fire was instrumental in breaking German defensive cohesion during the critical opening phase. Soviet doctrine for employing rocket artillery had evolved into a sophisticated system by this stage of the war. Fire planning began days before offensive operations, with reconnaissance aircraft and ground observers identifying German defensive positions, artillery batteries, command posts, and logistics areas. These targets were plotted on maps and assigned to specific rocket artillery regiments based on range and priority. Guards mortar regiments received firing positions selected to provide concealment while allowing rapid displacement after firing. Typical positions were in forests, behind hills, or in villages where buildings masked launcher trucks. Multiple alternate positions were prepared, allowing regiments to fire, displace, and fire again from different locations within 30 to 40 minutes. Fire missions were centrally controlled through division or corps artillery headquarters. Forward observers could request rocket fire, but actual authorization came from senior commanders who coordinated all artillery assets. This centralization ensured that rocket artillery, with its limited ammunition capacity relative to conventional guns, was employed against high-value targets where massed fires would achieve decisive effect. The standard firing procedure for a Guards mortar regiment had become highly refined by 1944. Upon receiving a fire mission, the regiment would move to its pre-selected firing position. Launcher trucks deployed in line, typically 50 to 100 meters apart to minimize casualties if German counter-battery fire arrived. Each launcher crew oriented their rails toward the target area using magnetic compass and basic angle measurements. Elevation was set using simple clinometers. The crude fire control was adequate given that individual rocket accuracy was never the goal. On command, all launchers in the regiment fired simultaneously or in rapid sequence. A typical regiment with 36 BM-13 launchers would fire 576 rockets in approximately 30 seconds. The entire salvo, over 24 tons of high explosive, would impact a target area roughly 1 kilometer square. Anything in that kill zone faced near certain destruction or disablement. Immediately after firing, launcher crews reloaded rockets from supply trucks that accompanied each battery. Reload time varied from 10 to 20 minutes depending on crew training and experience. During this vulnerable period, security elements watched for German counterattacks, while the regiment prepared to either fire again or displace to alternate positions. If German counter-battery fire threatened, the regiment would displace without reloading, abandoning the firing position and moving to alternate locations several kilometers away. The mobility that made the Katyusha system revolutionary also made it survivable. German artillery could destroy the firing position, but the launcher trucks were already gone. Gefreiter Klaus Richter, serving with the 197th Infantry Division during the retreat from Belorussia, described the frustration of facing an enemy that could strike with impunity. We learned to recognize the sound of Stalin's organ immediately. The moment we heard the shrieking, we knew we had perhaps 20 seconds before impact. There was no effective defense except dispersal and hope. Our own artillery attempted counter-battery fire, but by the time our observers identified the Soviet launch positions and called in fire missions, the Russians had departed. They could strike us repeatedly while our guns fired at empty forest. The psychological toll of Katyusha attacks accumulated over time. German soldiers who survived individual attacks often developed what Soviet intelligence documents described as rocket hysteria, a condition characterized by extreme anxiety, inability to function under fire, and sometimes complete psychological breakdown. Medical records from German field hospitals treating Eastern Front casualties show increasing cases of combat fatigue and psychological trauma, with rocket fire frequently cited as the precipitating cause. Dr. Ernst Weber, a German military psychiatrist treating casualties evacuated from the Eastern Front to hospitals in Poland, documented the phenomenon in reports that survived the war. Soldiers exposed to repeated rocket attacks exhibit symptoms distinct from conventional shell shock. They describe overwhelming terror during attacks, a sense of helplessness and doom. The distinctive shrieking sound causes visceral fear responses. Many patients report nightmares weeks after evacuation from the front. Some are unable to tolerate any loud noise. The psychological casualties from rocket fire often exceed the physical casualties, though this is difficult to quantify statistically. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The German military's inability to counter Soviet rocket artillery stemmed from multiple factors: industrial, organizational, and psychological. Industrially, Germany could not match Soviet production rates. Even at peak production in 1944, German factories manufactured approximately 500 Nebelwerfer launchers monthly, compared to Soviet production exceeding 1,000 rocket launchers of all types. This disparity reflected broader industrial imbalances. The Soviet Union, despite losing significant territory and industrial capacity, maintained and even increased production through factory evacuation, longer working hours, and ruthless prioritization of military production. Organizationally, German artillery remained wedded to precision fire doctrine. German artillery officers were trained to engage specific targets with minimum ammunition expenditure. This doctrine made sense given Germany's chronic ammunition shortages, but it meant German artillery could never achieve the mass shock effect that Soviet rocket artillery delivered routinely. German Nebelwerfer units fired planned barrages according to schedules determined hours in advance. Soviet Katyusha regiments fired responsive missions within minutes of target identification, providing direct support to advancing infantry and tank units. Psychologically, German soldiers never developed immunity to Katyusha attacks. Unlike conventional artillery, where soldiers learned to assess danger based on sound and adjust behavior accordingly, rocket attacks arrived too suddenly and overwhelmingly for psychological adaptation. Veterans with months of combat experience reacted to rocket fire with the same terror as new replacements. The weapon's effectiveness did not diminish with familiarity. If anything, soldiers who had survived multiple attacks became more fearful, knowing that survival was largely a matter of chance. The advance into Germany proper in 1945 brought Soviet rocket artillery to its final, most intensive employment. As Red Army forces crossed into German territory, Guards mortar regiments participated in every major offensive operation. The Vistula-Oder offensive in January 1945, the East Pomeranian offensive in February and March, and finally the Battle of Berlin in April and May, all featured massive rocket barrages as integral components of Soviet tactical operations. The Battle of Berlin represented the culmination of Soviet rocket artillery's wartime evolution. Over 400 rocket launcher systems concentrated around the German capital. The preparatory bombardment, beginning on April 16, 1945, was the most intensive artillery preparation of the entire war. Soviet forces fired over 1 million conventional artillery shells and approximately 200,000 rockets in the opening 24 hours. Obergefreiter Martin Schneider, defending Berlin with a Volkssturm unit composed of teenage boys and elderly men, kept a diary during the final days. His entry for April 16th conveys the horror of experiencing modern artillery warfare's full fury. The bombardment began at dawn. We had been told to expect heavy fire, but nothing prepared us for this. The entire sky filled with fire and smoke. Stalin's organ struck our positions repeatedly. Each attack was like the end of the world. The boys in my unit, some barely 16 years old, broke completely. They cried, they prayed, they begged to surrender. I could not blame them. I am 48 years old, a veteran of the Great War, and I have never experienced such terror. This is not war as we understood it. This is industrial annihilation. The Soviet assault on the Silo Heights, the fortified positions defending the approach to Berlin, demonstrated the Katyusha's effectiveness against prepared defences. German forces had constructed elaborate fortifications, with interlocking trenches, concrete bunkers, and carefully sited artillery positions. Soviet intelligence had identified these positions through aerial reconnaissance and ground observation. On April 16th, massed rocket fire systematically engaged each defensive position before Soviet infantry and tanks attacked. The results were devastating. German casualty reports, fragmentary and incomplete due to the chaos of the battle, suggest that over 60% of casualties during the initial assault came from artillery fire, with rocket attacks causing disproportionate losses relative to the number of rockets fired compared to conventional shells. More significantly, the psychological effect broke unit cohesion. German units that might have conducted effective defense instead fled their positions or surrendered en masse. Hauptmann Werner Hoffmann, who had witnessed the first Katyusha attack near Orsha in July 1941 and had survived Stalingrad's encirclement, was not present at Berlin. He remained in Soviet captivity, where he would spend 12 years before repatriation to East Germany in 1955. But his diary, confiscated in 1943, provides bookends to the German experience of Soviet rocket artillery. His first entry, describing confusion and terror at an unknown weapon, parallels the final entries of soldiers like Schneider, who faced the fully mature system in overwhelming mass. The final statistics of Soviet rocket artillery production and employment during World War II are staggering. Total launcher production exceeded 10,000 units across all types, BM-8, BM-13, and BM-31. Total rocket production exceeded 12 million units. Soviet Guards mortar units fired approximately 10 million rockets during the war, delivering roughly 50,000 tons of high explosive onto German forces. These numbers, while impressive, do not fully capture the weapon's impact. The Katyusha's true effect was psychological. It represented Soviet industrial capacity, organizational flexibility, and tactical innovation. For German soldiers, each Katyusha attack reinforced a terrible reality. They faced an enemy that could outproduce, out-innovate, and out-fight them. The post-war period saw Soviet rocket artillery become a standard component of artillery forces worldwide. The success of the Katyusha system inspired similar developments in multiple countries. The United States developed multiple rocket launcher systems during and after the war. China, supplied with Soviet equipment, became a major producer and user of rocket artillery. Even Western European nations, initially skeptical of rocket artillery's value, eventually adopted similar systems. The doctrinal lessons of Soviet rocket artillery employment influenced military thinking for decades. The emphasis on mass fires, rapid deployment, and shoot-and-scoot tactics became standard for all modern rocket artillery systems. The integration of rocket artillery into combined arms operations, pioneered by Soviet forces during World War II, remains current doctrine in contemporary military organizations. For the German soldiers who faced Katyusha fire, the experience left permanent psychological scars. Post-war studies of German veterans showed elevated rates of anxiety disorders, acoustic sensitivity, and post-traumatic stress among those who had served on the Eastern Front. Many specifically cited rocket attacks as their most terrifying combat experiences, more frightening than close combat, tank attacks, or conventional artillery. Gefreiter Otto Kranz, who had survived the Moscow counteroffensive in December 1941, returned to Germany after 5 years in Soviet captivity. In a 1952 interview with German researchers studying veteran experiences, he reflected on his wartime service. "I fought for 3 years on the Eastern Front. I experienced every form of combat, but the worst, the thing that still gives me nightmares, was Stalin's organ. That terrible shrieking sound haunts me. Decades later, I cannot tolerate fireworks or loud machinery. The sound triggers memories I cannot control. I see the smoke trails. I hear the shrieking. I feel the terror of knowing that in seconds I might be dead. Krantz's testimony, echoed by thousands of other veterans, reveals the Katyusha's lasting psychological impact. The weapon had succeeded not merely through its physical destructive power, which was considerable, but through its ability to induce terror that persisted long after the war ended. The German military's own assessment, conducted by surviving general staff officers in the immediate post-war period, acknowledged Soviet rocket artillery's revolutionary nature. General Heinz Guderian, former chief of the General Staff, wrote in his memoirs, "Soviet rocket artillery represented one of the war's most significant innovations. While we Germans prided ourselves on technical sophistication, the Soviets demonstrated that simple, mass-produced weapons employed with sound doctrine could achieve decisive results. The Katyusha was not individually superior to our Nebelwerfer, but they produced tens of thousands, while we produced thousands. They employed them aggressively and flexibly, while we used ours cautiously and rigidly. The result was Soviet artillery superiority that contributed significantly to our defeat." Guderian's assessment, notable for its candor, reflected a broader recognition among German military professionals that they had underestimated Soviet capability. The initial assumption that the Soviet Union possessed only numerical superiority compensating for technical inferiority had been comprehensively disproven. Soviet forces demonstrated innovation, particularly in rocket artillery, that matched or exceeded German achievements. The technological legacy of the Katyusha extended beyond military applications. Soviet rocket scientists who worked on artillery systems during the war later contributed to ballistic missile development. The same techniques for mass-producing simple, reliable rocket motors proved applicable to larger missiles. Some historians argue that Soviet success in early space exploration, culminating in Sputnik's launch in 1957, owed something to the industrial and technical base developed during wartime rocket artillery production. The human stories behind the statistics provide essential context. Captain Ivan Flyarov, who commanded the 1st Katyusha battery and fired the first combat salvo near Orsha in July 1941, was killed in action on October 7, 1941, near Vyazma. His battery, surrounded by German forces, destroyed their launchers rather than allow capture and fought to the death. Flyarov was posthumously awarded the Hero of the Soviet Union, the nation's highest decoration. Thousands of other Soviet soldiers served in Guards mortar units throughout the war. Casualty rates, while lower than infantry, were significant. German forces specifically targeted rocket artillery positions when identified. Soviet crews operating in forward areas faced the same dangers as other combat troops: artillery, fire, air, attack, and ground assault. The mobility that protected them during firing missions could not shield them from all threats. The industrial workers who produced rockets and launchers also contributed to victory. Factories operated around the clock, with workers putting in 12 to 16-hour shifts. Many were women, who comprised over 60% of the workforce in Soviet munitions factories by 1943. The simple, robust design of Katyusha components meant that semi-skilled workers could manufacture critical parts, allowing rapid training and deployment of labor. One such worker, Anastasia Petrova, worked at a Moscow factory producing M13 rockets from 1942 through the war's end. In a 1985 interview, she recalled the experience. "We worked every day, sometimes sleeping at the factory when production targets were urgent. We knew that every rocket we produced would be fired at the fascists. We knew that German soldiers feared our Katyushas. We were not just factory workers. We were soldiers in the industrial army, fighting with our hands and our labor to win the war." Petrova's testimony, representative of millions of Soviet workers, illustrates the total mobilization that characterized the Soviet war effort. Every rocket, every launcher, every component represented countless hours of labor by workers who understood their role in the larger struggle. This collective effort, multiplied across thousands of factories and millions of workers, produced the material superiority that overwhelmed German forces. The strategic implications of Soviet rocket artillery extended beyond tactical battlefield effects. The Katyusha demonstrated that the Soviet Union, dismissed by many as a technologically backward nation, could innovate and mass-produce advanced weapons systems. This realization influenced post-war assessments of Soviet military capability and contributed to Western respect for Soviet military power during the Cold War. German prisoners of war, interrogated about their combat experiences, consistently cited Soviet rocket artillery among the most effective weapons they faced. These testimonies, collected by Soviet intelligence services and later by Western researchers, provide valuable insights into the weapon's psychological impact from the enemy's perspective. Oberst Heinrich Wagner, the artillery officer whose observations appear throughout this narrative, provided perhaps the most comprehensive assessment during his post-war interrogation. His analysis, preserved in Soviet archives, runs to over 40 pages of detailed technical and tactical observations. Wagner's conclusion summarizes the German experience. Soviet rocket artillery succeeded because it exploited German weaknesses while maximizing Soviet strengths. We Germans valued precision and economy of force. The Soviets valued mass and shock effect. Rocket artillery achieved mass and shock effect more efficiently than any alternative. We could not counter it because we lacked the industrial capacity for equivalent production and the doctrinal flexibility for equivalent employment. This represented one of our fundamental failures in the East. The weapon that had terrified German soldiers from Orsha to Berlin achieved its purpose not through technical superiority, though the BM-13 was a sound design, but through the combination of adequate technology, mass production, and innovative employment doctrine. The Soviets had created a weapon system that amplified their advantages in industrial capacity and manpower, while compensating for their disadvantages in technical sophistication and tactical flexibility. The Katyusha's success offered broader lessons about military innovation. Sometimes revolutionary advances come not from perfecting existing systems, but from creating entirely new systems that change the paradigm. Soviet rocket artillery did not attempt to match conventional artillery's precision. Instead, it redefined artillery's role, emphasizing saturation over accuracy, shock over sustained fire, and psychological effect over simple physical destruction. For the German soldiers who faced this weapon throughout the war's final 4 years, the Katyusha became synonymous with Soviet military power. The distinctive shrieking sound, the smoke trails against the sky, the sudden overwhelming impact, these became the signature of an enemy that had transformed from apparently beaten to seemingly invincible. The psychological journey from confidence to terror to resignation mirrored Germany's broader military trajectory. The veterans who survived and eventually returned home carried these memories for decades. Their testimony, preserved in letters, diaries, interviews, and official military records, provides invaluable historical documentation of combat's psychological dimensions. The Katyusha appears repeatedly in these accounts, cited more frequently than any other single weapon system as the most feared and most devastating experience of Eastern Front service. The weapon's unofficial name, Stalin's organ, itself reveals the psychological impact. Unlike clinical military designations, the nickname conveyed soldiers' visceral response to the weapon. It was personal, it was frightening, it was associated with the Soviet dictator, whose name represented implacable hostility. German soldiers, hearing the shrieking sound, knew that Stalin himself, embodied in his organ, was reaching out to destroy them. The terror, inspired by Katyusha fire, never diminished, even among veteran troops. Soldiers who had adapted to conventional artillery, learning to judge danger and react appropriately, never adapted to rocket attacks. The speed, the sound, the overwhelming nature of the weapon defied psychological accommodation. This sustained effectiveness throughout years of combat distinguished rocket artillery from conventional weapons, whose psychological impact often decreased as soldiers gained experience. The final Soviet rocket barrage of World War II in Europe occurred on May 2, 1945, during the final assault on the Reichstag building in Berlin. Guards' mortar units fired approximately 2,000 rockets in a 10-minute period, saturating the area around the symbolic heart of Nazi Germany. German defenders, mostly SS troops and Volkssturm militia, offered minimal resistance after the bombardment. The psychological effect of the barrage, combined with the knowledge that the war was effectively over, broke what little remained of German will to resist. The Reichstag fell later that day. The famous photograph of Soviet soldiers raising the red flag over the building's ruined dome became one of World War II's most iconic images. Less celebrated but equally significant was the role that rocket artillery played in making that moment possible, breaking German resistance and paving the way for Soviet infantry to seize their objective. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.